Hi, everybody. Thank you for attending my talk. My name is Aaron Lee. I'm a developer advocate at Solus. And today I'm going to be talking about topics and partitions, distributing, filtering, ordering, and scaling in your event-driven architecture. So at the start of the talk, we're going to do a little bit of publish subscribe, describing what this architectural communication pattern is, look at some topics and their examples, talk a little bit about filtering, options for scaling your consumers for load balancing, and that will lead naturally into partitioning. So to start off the talk, I have a few claims that I'd like to make. Claim 1, EDA requires one-to-many asynchronous communication. This is contrasting to point-to-point style communication, more legacy stuff, or even modern RESTful, blocking synchronous communication, which is also kind of one-to-one. EDA requires one-to-many asynchronous. Claim 2, most use cases require reliable delivery, or what we might call persistent delivery. Of course, there are use cases like trading platforms where ultra-low latency is required. That might be best effort delivery, or maybe an IoT sensor data that, if you lose a few of those, it might not be so bad. But most use cases out there require persistent style of delivery of messaging. And number 3, successful apps hopefully require horizontal scaling. As load goes up, we need some way of scaling our consumer applications to be able to handle increased load, and we're going to look at some options around there. Okay? If you don't believe those claims, be sure to check out some of the other talks. I'm sure other people in the EDA Summit will be kind of going on about these particular things quite a bit. So yeah, let's dive into it, all right? So publish subscribe, it is the fundamental communication pattern in event-driven architectures. Now it's based on the observer pattern, which was made up by the Gang of Four, if you remember your software design patterns. And it's where one or more observers want to be informed about state changes or events with a particular subject. And the way they do that is the observers will register with the subject, and whenever that subject changes state, it will notify the observers via a callback. Think of a GUI, right? If you have a button, which is your subject, every time that button gets clicked, it runs an event handler. It calls an event handler, which your application will subscribe to and be notified of button changes. The observers do not poll the subject. You are not polling the button to find out if it's been clicked. You just want the button to tell you when it's been clicked, an event-driven style of communication. So publish subscribe builds on that and implements that in a kind of distributed communication way. The subject and observers are decoupled. One thing you'll notice about the observer pattern is that the subject needs to maintain this list of observers, and then using this update method actually notify the observers when something happens. So there's an inherent coupling there that the subject needs to know who all the observers are. We'll see in publish subscribe that kind of goes away. Subjects in the publish subscribe will use messages to send their data, and the use of topics is to route which observers want which particular piece of data. So topics, right? What is a topic? Here's a definition I pulled off of dictionary.com, a subject or theme of conversation or discussion or one of its parts. Now that's pretty generic, not very computing related, but we're going to see how this definition actually comes in handy in a little bit. Now one thing I want to kind of make clear right at the beginning is that topics are not log files. A lot of developers, I do a lot of developer workshops, have this, they learn about EDA, they learn about one particular implementation of EDA, where in their mind, a topic is a log file. And that's not true. Topics are essentially just a concept of the publish-subscribe pattern. So let's talk about that. In a publish-subscribe pattern, you have publishers or producers, you'll have consumers or subscribers, and they are going to be communicating via messages. These messages are tagged with a topic, which is like a label or an address or a string, and that's going to be used to route the messages to the different subscribers. And in most cases, there's a broker in the middle, a brokered architecture, and the broker is maintaining all of the state, which subscribers are interested in which topics, and as the messages arrive at the broker decides who's going to get it. So it's this way that it's a very decoupled architecture because the subscribers don't necessarily know where the publishers are. The publishers certainly don't know how many subscribers there are, and it's not their job to go and send this message. So the broker acts kind of like the post office for delivering this mail rather than each application going and hand delivering it like a REST post directly to a particular endpoint. So the broker manages all of that kind of communication. Now, in terms of topics, there are kind of two main camps, the way that I see it. There are what we might call object topics, where topics are implemented as broker objects, often as log files. A lot of streaming log-based application event brokers, our topics are log files. They are created, they're configured, they exist on a broker. They're like a physical thing almost. Examples of this are Kafka, Pulsar, even the new Rabbit MQ streams. These are all implemented as a kind of append-only logs that exist in the broker. Now, contrast that with what you might call smart topics, where topics are essentially message metadata. They exist as part of the message. They are dynamic, they're ephemeral, they're per message. Each message has its own unique topic. They are multi-level, hierarchical, and typically the topic will describe what is inside the actual message payload or content. Examples of these are Solus PubSub Plus, MQTT, NATS, even old school Rabbit, and going back to the 90s, TIBCO RV had a hierarchical topic structure. So one is logs files on a broker, the other is describing message metadata. These are the kind of two styles. So let's look at an example. I have US flight position data broadcasting from all over these different radar stations, sending out this big payload here that includes like the source system, the location, the flight number, the aircraft carrier, destination airport, arrival airport, altitude, ground speed, all that kind of stuff. This is the payload of the data that I'm sending. But how do I want to address that? How do I want to label this data so for my downstream consumers that want to ingest this data? Now, if I was using Kafka, I might, I'm publishing to a file. I have to have a name for this thing. If I want all of my flight position data for the whole US to go into one big topic, I could call it flights.us.position, for example. One big file with all the data. So if you're just reading all of that data, that might be a great topic for you. Maybe I want more specific stuff. I could maybe have a topic per carrier, right? So I could have flights.us.position.air Canada, one for United, one for, whoever else. You might have dozens or hundreds of topics this way. But if you want to receive all of the data, you're going to have to connect to all of those topics, all of those files. You could even say, well, I want to have one topic per flight plan. And there's thousands, tens of thousands of these per day, and they're dynamically changing. And because these are, files on a broker, that could be a lot of files. And if you want to receive, again, the whole feed, you now need to connect to thousands or tens of thousands of topics. So not the most ideal, not typically the way that Kafka topics are architectured. Usually a lot more coarse-grained with kind of a lot of data in them. Versus, let's look at an MQTT example. MQTT has a hierarchical topic structure, very descriptive, very dynamic. And so our topic structure might look like, the first couple levels, flight US position. Then I could have the carrier operator. I could have the flight number as a topic level. I could even have the flight plan as a topic level. Even the latitude, longitude, and altitude could be part of the topic string. And so, as these planes are flying around and the radar station keeps reporting new positions, this position is changing. So the latitude, longitude is constantly changing. So every single message that I publish is going to be on a different topic. So lots and lots of different topics. Well, how many topics are there? Fun facts. Let's take a look. How many topics do you think you can make using this kind of pattern? Well, let's kind of restrict it a little bit. So let's say we have up to 6 topic levels. That last airplane one had 9 levels, so let's reduce it a little bit. I'm going to have up to 8 characters per level, so somewhere between 1 and 8 characters per level. Let's restrict it to just the alphanumerics, right? A to Z, uppercase, lowercase, and the numbers. So 62 possible characters, no weird Unicode or anything. So my total max topic length is going to be around 53 characters, so somewhere between 12 to 53 characters. So it's going to look something like this, right? Level 1, level 2, level 6. How many topics, unique topics, do you think you can build with this topic structure? Take a guess. I'll pause for a second. Think about it. Okay? 10 to the 86 possible combinations based on this pretty simple topic structure, which is a number that looks something like this. Or to put it more in perspective, that's essentially just slightly more than the number of atoms in the observable universe. So yeah, that's quite a bit. That is a very unique way of describing your data. Obviously, you could use more characters than that, longer topics than that, more levels than that. So you can really see that you have very dynamic and large number of topics. You could not have that many files sitting on a Kafka broker, for example. So I got all these topics, I got millions and billions and trillions. How do I subscribe to this? Well, we're going to be using wildcards. A single topic wildcard, as a consumer, I can attract an infinite, essentially, number of different topics, published topics. Now you'll notice that different brokers use terminology slightly differently. Topics, subjects, they have different level separators between the levels of their topics, a slash or a period there. But they all have a concept of a single level wildcard, which will match everything up to the next topic level. There's a multi-level wildcard that must occur at the end of the topic subscription, which essentially says if I've matched up to here, give it to me. I don't care what the rest of the data is. And I'm pretty sure Solus is actually the only broker out there that actually supports a prefix style single level wildcard. So you could subscribe to ABC star, and as long as that topic level starts with ABC, you'll get a copy of it. So we'll look at some use cases for that in just a little bit. So let's go back to that definition of a topic, right? So a topic is a subject or theme of conversation or discussion or one of its parts. Okay, so in my event-driven architecture, businesses, processes are streams of events. These are discussions. These are systems describing what is happening into them, state changes that are occurring within them, factory floors, machines, payment gateways. They are generating events that discuss what they are doing. And so events are a topic, which is your subject or theme, and a payload, the rest of the data, everything that you want to send along. And so when you start thinking, okay, well, I need to describe my topic, my event, I want you to think noun plus verb plus metadata. And the metadata that goes into your topic is essentially anything that you might want to route or filter on belongs in your topic string. And anything that doesn't, you can just leave in the payload. So let's look at some topic examples here, smart topic ones. So if I was publishing to this topic, you could pretty much easily see that I'm creating an order for Ben & Jerry's ice cream for Unilever in the European zone, for example, right? Pretty descriptive. If I was wanted to subscribe to some of that order feed, I might say, I want to listen to all new orders that have been created in Europe. I could do that with that topic subscription. Or perhaps I want to listen to all orders, create, change, cancel for ice cream. Doesn't matter what geo that that order is coming from. You can do it with that topic subscription. A payments use case. Here you can see I have some kind of corporate high value payment from the UK for pound sterling versus US dollar. That's been canceled. Okay? Again, very descriptive. And as a subscriber, I might want to listen to all payments coming out of the UK, whether they've been canceled or created. Or I could have another microservice that's subscribing to all payment cancels, regardless of what location they are coming from. One last one, stock market, right? New York Stock Exchange is generating tons of pricing information. You can see here that this is obviously a bid quote for Google, someone is trying to sell some Google stocks. Here's what the price is for it. And I might want to say, all right, I want to subscribe to all Google stock, but not just quote data. Maybe I want to listen to all trade data and all reference data as well. You could do it with that particular subscription there. Or maybe I want to listen to all of the quote data coming out of New York Stock Exchange. You could do it with that last subscription on that side. So using wildcards or kind of the actual topic levels, you can be very specific or very fine-grained or very generic about what type of data you want to receive as a consumer. So a lot of the filtering happening there in the broker. So speaking of filtering, in Kafka, there's really very little filtering that happens in the broker, if at all. There's basically messages that are published to a topic, to a file, and then if you want to do any filtering of that, you have to pull all of that data out of the topic and then do some processing, looking at the payload, deserializing it, and essentially doing content routing on that on each individual record. So you need something like K-streams or a KSQL-DB. These run client side. These are outside of the broker to look at that data. And then, if you want to have a filtered view of that for another application, it would typically write that back into the Kafka broker as a filtered topic. So writing it back again. Now this is versus something like Solus, where you have topic filtering as messages are coming in. Each subscriber might have different subscriptions, as we just talked about on that last slide. We also have the concept of selectors, right? An optional section of the user properties of each message. You can perform a little bit more complex routing. I put a star there because it's not typically recommended for the most part. It's not as performant as topic filtering, and a lot of use cases that require selectors, people using MQ, EMS, other JMS brokers, a lot of those kind of selectors can be actually done with topic filters instead. So we always try to recommend that. And if all else fails, of course, you can always do content routing, pulling the event streams or the filtered event streams out of the broker, and the client will actually look at the data. You could use something like Flink to perform similar types of analytics that like K-Streams does, joins, and stuff like that, publishing it back to another topic if you wanted it to, or sending it to some downstream analytics. So a little bit more kind of flexibility in terms of specifically what type of filtering you want, and the broker handles a lot of that for you. In Solus case, for example. Okay, so let's switch gears. Now we have our app, we have received our filtered view or our view of our event streams. As load goes up, our wildly successful app needs to scale. I need multiple ways of consuming this data. So what are some of my options, right? Those familiar with JMS brokers will know about non-exclusive queues, a queue where multiple consumers bind into it, and the broker will essentially round robin deliver messages to the different backends. RabbitMQ also, I think queues are by default a round robin queue unless you have kind of a single access consumer configured. There's another similar concept called shared subscriptions that's in MQTT version 5. Solus also implements this for our direct messaging. And again, it's a round robin or a randomized delivery to everybody in a subscription group. So if I have 5 consumers, they're all subscribed to the same thing within that one group, the broker will pick one of them for each message. So rather than a round robin load balance delivery rather than like a one-to-many. Now these are great if each message or each event that you're processing is kind of atomic or independent of all others, and you just need to like load balance and like kind of load balance evenly. But if you need context-aware load balancing, sticky load balancing, say I have a new order come in and then I want to cancel that order, I want to make sure that the consumer that gets that cancel is the same one that got the new. I want to make sure that there's maybe for stateful microservices, you need some concept of sticky load balancing. And so that's where partitioning really comes in. Kafka implemented partitioning as a way to do load balancing within their topic, Pulsar, and Solus now has partitioning as well. So you can really do sticky load balancing across with a non-exclusive kind of style of delivery. Multiple consumers consuming in parallel. And the way that works is events are keyed and they will get delivered to a particular partition. I have a slide on that in just a minute. We'll talk a bit more. But there is one other way that I think I just want to mention. In Solus, we have this concept of topic sharding. Sharding, partitioning, kind of same thing. But because of that prefix wildcard capability, I can partition at the topic level. And this has actually been used by a lot of our financial services customers. Like the New York Stock Exchange, every stock price or every stock ticker is an A to B, C, or D, or up to Z. And so I might have one set of caches that are listening to A star, B star, C star, another set of caches that's D star, E star, F star. And so I can actually shard or partition at the topic level before it comes to my queue or before it comes to my subscriber if it's a direct subscriber. So a real extra bit of flexibility there using that prefix level wildcarding. And you can mix and match, which gives you some pretty powerful options. But we're here to talk about partitioning. So let's look at partitioning. Context-aware ordering. So the way that this works is partitions will, the publishers will add a key to their message, right? So when I publish my message, my record in Kafka speak, I publish a key associated with that, and there's going to be some kind of hashing or lookup that will determine for that particular key which partition it maps into. And hopefully you have a large enough key space that you get a nice even distribution of your keys. And then your subscribers, if you have multiple subscribers, they'll each bind to a different partition. Each partition maps to one subscriber. A particular subscriber could connect to multiple partitions, but each partition only connects to one. And that way we know that related messages for that particular ID, that order ID or that employee ID or that flight number are always going to be landing on the same partition. Essentially turning your broker into kind of a ball sorting machine. You know, every color I know is going to land on the same partition. So whether, that's order IDs or employees, I know that I'm going to have ordering within a particular, for a particular order or employee or whatever. So very, very useful. Kafka, this is topics, by the way, so it's not a file. Each partition is actually a file. So if you have a Kafka topic with like 20 partitions, it's actually 20 files on the broker. It's a little bit, that's how they've implemented it. Okay, that's how I'm not going to go into all the kind of like rebalancing and all the other ways that you need to use and learn to use partitions. My colleague Rob Tompkins actually has a talk here at EDA Summit. He goes into detail on Solace partitions and Kafka partitions and a little bit more in depth. So be sure to check that out if you want more details. But yeah, one of the big benefits about Kafka is that it kind of combines queuing style delivery, which is persistence and ordering, with a publish subscribe style of delivery, like one to many, right? I can have multiple apps all kind of receiving that message feed. But this is also actually one of the big drawbacks about Kafka is that they tightly couple their queuing and their publish subscribe delivery. What do I mean by that is because the addressing of the data and the addressing of the storage is essentially the same thing, this name topic object living on the broker, there's a tight coupling there. I'm publishing messages to a location, to a file, rather than describing what's actually inside each particular message. And so if I want to do any additional filtering, I can't do that at the topic level. I need to pull all of the data out of the topic, and I need to do that within my consumer group, my microservice, my K-streams, my whatever is outside of the broker. I need to do my filtering kind of there. Now contrast that with Solace, who've kind of decoupled their storaging and their addressing. So the addressing is the message metadata, the topic, and the persistent storage is essentially the queue. That is the named object on the broker. But those are two separate things. Remember, like smart topics are message metadata that belong to the message and describe the message, and the queues will attract whatever messages they want based on subscriptions. So in this case, the queues have the subscriptions on them, and they peel off parts of that topic or that event stream that they want to consume and store. And so this allows for a lot of flexibility and performance with regards to filtering routing within the broker, not even like needing to use additional microservices or clients, so that your apps are only getting the data that they want. They don't need to like throw away stuff that they don't need. So you can see a couple of examples here. I got my Air Canada app that is subscribing to specifically the Air Canada topic level, and it doesn't matter about anything else. My second app down here, Washington, D.C. app, you'll see I'm actually subscribed to star for the carrier, star for the flight number, star for the flight plan. But this, latitude, longitude, 37 north, 78 west, is essentially a 1 degree bounding box around Washington, D.C. And so if I subscribe to this, and if a plane is flying in that area, its topic will match up with this subscription. And it's not doing arithmetic. This is just string matching. But I can essentially do location-based filtering using topics. I don't have to look at the payload, and I don't need to use anything else, which gives you, again, just a lot of flexibility that the broker is kind of managing this filtering for you. Now, one thing you might say, well, if this message is landing on multiple queues, I have multiple queues attracting this particular message topic, isn't that like costing a lot of extra disk space? Kafka, it's writing to a file and everybody reads from that one file. Well, that's just a broker implementation. TIBCO EMS, old school RabbitMQ, yes, every time a message lands on a queue, it's actually getting written to disk. So if you have large fan out, like 1 to 5, 1 to 10, it's actually getting written to the disk multiple times. Luckily in Solace, everything is passed by reference. It's all pointer based. We only write it to the disk once, and just each queue has a pointer to that particular message on the disk. So a lot more, efficient in terms of your storage. So again, don't worry about having a large fan out. And one example I didn't have here is I want to receive everything. Not Air Canada, but I am FAA, for example. I want to receive every single flight. I would just put a greater than there instead of the AC, and now I'm receiving the full feed. Again, one-to-many style of communication, and that data is only stored once on the queue, on the disk. Now, of course, this decoupling applies to the partitioning strategy as well. Because in Kafka, the topic and the partitions within it they're used by every single application that wants to receive data from it. That means if I have a really big app that needs a lot of partitions and a really tiny app that really doesn't, it still needs to connect to all of the partitions. And so what happens is if my big app needs to be even bigger and I need to add more partitions, well, now all the other apps that are listening to that same topic also need to, reconnect, they rebalance, they have to go through, they get impacted because they're using a shared partition. Whereas in Solace, I might have my small app here using an exclusive queue. It's subscribed with an exclusive queue, or it could have maybe 2 partitions listening to its part of the feed. My big app here could have lots and lots of partitions. And if, for example, United and Air Canada merged and suddenly I need to start consuming the United data as well, I'll add a new topic subscription to my queue, maybe add some new partitions. Only that big app is going to get impacted from that repartitioning. The small apps and every other app don't really matter. So partitions per group rather than partitions per topic. That's kind of one of the big differences there. Anyway, I'm pretty much out of time. I really wish I had more to talk about other things like, because this is persistent delivery, we need to talk about message receipts, acknowledgements, checkpointing every 10 seconds versus per message acknowledgement that you get in Solace. I don't have time. I will have other videos and things coming out at some point. Be sure to stay tuned for that. If you want to come find me, you can probably most easily do that on the Solace community. Scan the QR code. It'll take you right there. We are going to make a demo of our partition queues capability. We'll have more details on rebalancing and some of the application changes that you need to do. But yeah, thanks for coming to my talk. I hope you enjoy the conference. Again, my name is Aaron, and yep, thanks, and see you later.